Hello everybody, welcome back to my channel AKB Tutorials. I am Ashok from AKB Tutorials. So in this channel we are discussing various topics related to mechanical engineering. So today we are going to discuss about shear force and bending moment diagram on simply supported beam. So simply supported beam. The beam is also written in question paper as SS beam. So now in this beam, the beam is loaded with some kind of load. So we are going to discuss about shear force and bending moment diagram. The beam, the definition of beam, we know it is a horizontal member which one of the dimension is much larger than other two dimensions, and it takes loads in its axial vertical to its axial plane. So this is a simply supported beam. Simply if we draw a beam, so this is a simply supported beam. The beam is resting over two end supports. So let A and B are the end supports and a load which is acting at center, say W is the load which is acting at the center of the beam. Now this is a simply supported beam. The beam is resting over two end supports and let the ends are A and B. Now on the supports the reaction will develop. Because of this, say RA is the reaction developed at support A and RB is the reaction developed at support B. So beam is in equilibrium conditions. So there are two equations, that is static equations. So from this we can calculate RA plus RB, that is reaction at point A and reaction point B, which are acting vertically upward direction, that will be equal to the load on the beam which is acting in downward direction. So this is the first equation, that is first static equation, which will satisfy. Now second static equation we have to find, that is by taking the moments. So taking moment about point B, taking moment about point B, about point B. So if we take moment about this point, so the moment will be RA into the length of the beam. So say the length of the beam is equal to L. So RA into L, that will be a clockwise moment, and that will be minus W will give a moment about point B. So W into, as this is the central load, so length from here to point B, that is L by 2. So W into L by 2, and that will be equated to 0 because the beam is in equilibrium. So RA into L minus W into L by 2 is equal to 0, which gives RA into L is equal to WL by 2, or RA is equal to W by 2. So we have got the reaction at point A. Similarly, then we can determine from the equation number 1, that is RA plus RB is equal to W. So RB is equal to W minus RA, and that is equal to W minus W by 2, and that is also W by 2. So from this it is clear. So RA is equal to W by 2 and RB also equal to W by 2. RA is equal to W by 2, RB is equal to W by 2. If the load is acting at the midpoint of the beam, then the reaction will be equal. So you can say the load is symmetric load. So load is symmetric, then the reaction at point A and point B will be same. Now for drawing shear force and bending moment diagram, So we will calculate at the right side of the page, and the left side we will draw the diagram. So for shear force calculation, consider a section XX at a distance x from the left end. From the left end we have considered a section at a distance x. Now shear force at xx. So as per the definition of shear force, all the vertical loads acting to one side of the beam, one side of the section. So algebraic sum of all vertical loads acting to one side of the section. So xx section we have considered. So one side, only this side, left side, the load is acting, that is Ra. So shear force at section xx is equal to Ra. Now whether it is positive or negative. So we know this is the section. If right side is downward, positive. If left side is upward, positive. So this will give a positive shear force. So that means here at the left side of the section, Ra is acting in upward direction, so this will be positive. So we are writing it is positive. Now we will slide the section to this point. So we are giving the name, this point is equal to C. So first we will see shear force at point A. So when we will slide this section to point A, the x value will be 0, but we are considering one point right of point A. So shear force will be Ra, that is equal to W by 2. Now slide the section to point C. Point C means one point left to point C. So we will get shear force at point C is equal to W by 2. It remains same. Now considering another section, say YY section, which is at a distance y from left support. Okay. Now shear force at YY. Shear force at YY. First we will calculate the equation of shear force at section YY. Now algebraic sum of all vertical loads acting to left side of this or one side of the section, that is left side we are considering. So Ra is acting in upward direction and W is acting in downward direction. So Ra, which is acting in upward direction, that will be positive, and W is in downward direction, so it will be negative. So we can calculate Ra means W by 2 minus W is equal to minus W by 2. Now slide the section to point C. So we are sliding this section to point C, so we will get shear force at point C. So that will be, point C means one point right to point C. So that will remain same, that is minus W by 2. Slide the section to point B. So it will give shear force at point B. So that also will be equal to minus W by 2. With this information we can draw the shear force diagram. So for drawing, underneath this, draw two vertical lines and say this is the baseline. What is baseline? Now at point A, shear force is plus W by 2. With some scale measure this. This indicates W by 2. So now this remains constant up to point C. And at this point again, if we see at point C, so it will be minus W by 2. So at this point it will vary and the diagram will be like this. So that means this is W by 2, this also W by 2, and this is the baseline. This side is positive and this side is negative, and put the hatching lines. So this is the shear force diagram for the kind of loading on simply supported beam. The simply supported beam is loaded at the center with a point load, that is W. Now we will see the bending moment diagram for this beam. Now we will calculate the bending moment equation at the sections, that is bending moment at section XX. Now go to XX. Now what is the bending moment as per the definition? The algebraic sum of moments of all vertical forces acting to one side of the section consider. Okay, so if we consider XX section, left side only RA force is acting, so the bending moment will be RA into that distance is X is equal to W by 2 into X is equal to WX by 2. So that is the bending moment at section XX. Now if we slide the section to point A, the bending moment at point A will be W into X by 2, where X value, if we slide the section to point A, X value will be 0. So we can write W into 0 by 2. So that is equal to 0. Now slide the section to point C. So bending moment at point C is equal to W into X by 2. What is X value at point C? X will be L by 2. So W into L by 2 divided by 2 is equal to WL by 4. Now we will calculate the bending moment equation at section YY. So bending moment at section YY. So bending moment at section YY. So it is given by, so now bending moment at section RA will give a moment, that is RA into Y, because the section is at a distance Y. So this will be your clockwise moment. Now this W also will give a moment about YY section. So this will be minus, because it gives anti-clockwise moment, minus W into L by 2. W into L by 2. So it will be RA is equal to W by 2 into Y, W into RA into Y minus W into L by 2. RA means W by 2 into Y minus W into L by 2. So now slide the section to point C. So we will get bending moment at point C. At C, what is the Y value? The Y here. So now if we slide, Y value will be L by 2. So we will put bending moment at C, W by 2 into L by 2 minus, RA into Y minus W into Y minus L by 2. W into Y minus L by 2. So minus W into Y is equal to L by 2 minus L by 2. So that this part will be 0. So it will be WL by 4. Remain same. And slide the section to point B. So bending moment at point B. So that will be, just put Y value is equal to L, because at point B Y value will be L. So if we put Y value is equal to L, so is equal to W by 2 into L minus W into L by 2 minus L by 2. Y value will be L minus L by 2. L minus L by 2. So that will be 0. So with this information we will draw the bending moment diagram. So for bending moment diagram, first draw the baseline. So let this is the baseline. Now you have to find out whether the bending moment is positive or negative. So for this simply supported beam, the moment is acting like this, so the beam will take the shape of this, so that means bending moment will be always positive. Okay, so that is positive. So at point A, what is the bending moment? Is equal to 0. So it will start, the curve will start from here. Now at C, it is WL by 4. So let this one, this height represents WL by 4 at the center. WL by 4. Now join this line with a straight line, because variation is a linear variation. So that will WL by 4, and this will be positive, and put the hatching lines. So this is the bending moment diagram for simply supported beam acting under point load at the center. Now in this, the bending moment at the supports will be 0. That is the multi-choice question, as well as the bending moment at the center, it will be maximum, and it is given by WL by 4. WL by 4. Okay, this is all about the bending moment and shear force diagram for a simply supported beam under point load at the center. Now we will see the second case, that is the simply supported beam under point load not at the center. Now let this is the simply supported beam. The beam is under point load at a distance A from left end, and from right end it is at a distance B. So it is not central load. So let this point is A, this point is B. Now the point load is acting not at the center, where A plus B is equal to L. Okay, that is fine. Now the reaction will develop at the supports, they say RA and RB are the reactions developed at support A and support B. Now so RA, RB will be vertically upward loads, and that will be equal to vertically downward load. That equation will remain same, that is the balancing of forces in equilibrium condition. Now taking moment about point B, so we will get RA into A plus B, that is the moment produced by RA force about point B. RA into A plus B, that is clockwise moment, minus W will produce anti-clockwise moment, W into B, and that will be equal to 0. So from here we will get what is RA value. So RA is equal to WB by A plus B. So this is the first equation. What is solution? That is the reaction at support A. And what is the reaction at support B? So from equation number 1 we can get RB is equal to W minus RA, and that is equal to W minus WB by A plus B is equal to WA plus WB minus WB by A plus B is equal to WA by A plus B. So we have got this. So we can write here what is the RA, W into B by A plus B, and what is RB is equal to W into A by A plus B. So we have got the reaction. So for any problem, first we have to calculate the reactions at supports. So there are two supports. So RA and RB we have to calculate first. After that we will go for shear force and bending moment diagram. So for calculation of shear force, consider a section XX at a distance x from left end, which is at a distance x from left end. Now shear force at XX, shear force at XX section. So the equation will be shear force, algebraic sum of all vertical loads acting to one side of the section. Consider here we have considered this section XX, left side only RA force is acting. So RA, and that is acting in upward direction. RA is equal to WB by A plus B. So what we have got here? So we have written just. Now slide the section to point A. So we will get shear force at point A, that is equal to WB by A plus B. Slide the section to this point, say this point name is C. So we will get shear force at point C is equal to, also remain same, WB by A plus B. Now consider another section, that is YY section, which is at a distance Y from left support, Y from left support. Okay, so we'll get shear force at YY is equal to algebraic sum of all vertical loads acting to left of section YY. What are the forces acting, vertical forces? That is RA acting in upward direction, RA minus W in downward direction. So RA is equal to WB by A plus B minus W, and it will be WA by minus WA by A plus B. Okay, we have got this. Now slide the section to point C. So we will get shear force at point C, that will be minus WA by A plus B, and slide the section to point B. So we will get shear force at point B, that will also be minus WA by A plus B. So we have got the shear force at point C and point B. So with this information, draw two vertical lines from point A and B. First you draw the baseline. So first at this point A, what is shear force? WB by A plus B with some suitable scale. Take this measurement, WB by A plus B, and draw a horizontal line up to point C. Okay, then at point C it will change, so that will be WA by A plus B. So this width will be more, so WA by A plus B. So this one is equal to WA by A plus B from here to here. Okay, so this is positive and this is negative, and put the hatching marks. So this will be the shear force diagram for this beam. Now we will go for calculation of bending moment diagram. So at the section, we will calculate bending moment at section XX. So if we calculate the bending moment at section XX, what is the bending moment? This force will cause the bending moment about this section, that is RA into X. RA into X. What is RA value? Is equal to W into B by A plus B into X. Okay, now slide the section to point A. So we will get bending moment at point A. Bending moment at point A will be equal to at point A, X value is 0. So it will be 0. Now slide the section to point C. So bending moment at point C, where C, the length that X value will be A. So we can write WB into X means A by A plus B. So is equal to WAB by A plus B. Now go to section YY. So bending moment equation at section YY will be RA into this distance Y. So RA into Y. So that will give a clockwise moment and W will give a anti-clockwise moment. So minus W into this distance we have to give. What is the distance? Y minus A. Y minus A. So this is the equation of bending moment at section YY. Now slide the section to point C. So bending moment at point C will get RA means WB by A plus B into Y value is equal to A minus W into A minus A. So that will be 0. So that means it will give WAB by A plus B. It is same as at point C where, so this and this will be same. Now we will go for bending moment at point B. So bending moment at point B. So at point B, what is the Y value? A plus B. A plus B. Put WB by A plus B into Y. Y means A plus B minus W into A plus B minus A, and it will come 0. So we have got the bending moment at point A, point C and point B. So with this information we can draw the bending moment diagram. So for this, draw this vertical line, draw the baseline, and the bending moment will be positive. So at this point it is 0, at this point it is 0, and underneath point C, what is the value? WAB by A plus B. So this measure this height, WAB by A plus B, and the variation bending moment varies with Y, bending moment varies with X, means linear variation. So straight line variation. So just join these two. With the help of a straight line. So you will get the bending moment diagram for the beam, and it is also positive. Okay, this is all about the point load acting not at the center. So it is away from the center. Now we will go for another question, that is the beam is under uniformly distributed load. Simply supported beam, the beam is under uniformly distributed load. So under UDL. So for this, so let the beam, the whole length of the beam is under uniformly distributed load. Say the intensity of load is given by W per meter length. So W unit of W, it may be in kg, it may be in Newton, okay, or kilonewton, whatever may be. So the whole length we have considered that. Okay, now let this point is A and this point is B. Now total load on the beam. First we have to calculate the total load on beam. Total load on beam. So per unit it is W, say Newton. So length of the beam, let the length of the beam is L. So total load on the beam is equal to W into L. So this is also coming as a question, multi-choice question. Total load acting on the beam is equal to W into L. Now supports are at point A and point B. So the reaction developed at supports say RA and RB. So the first static equation, it will be RA plus RB, that will be equal to the vertically downward load W into L. Total vertically downward load is equal to W into L, and that will be taken by support A and support B, that is RA plus RB is equal to W into L. Now take moment about B. Take moment about point B. Moment about point B. About point B. Now if we take moment about point B, so RA will give moment RA into L minus, what is the total load acting on the beam? That is W into L. And the center of gravity of the load is exactly at the center, means the distance from point B will be L by 2. So this W into L, so this will give a moment, that is the moment will be negative because it will be an anti-clockwise sense. So this one is in clockwise sense, so we have taken positive RA into L minus W into L by 2. Okay, so that will be equal to 0 because beam is in equilibrium. Beam is in equilibrium, so the sum of the moments will give 0 value. So the RA into L minus W into L by 2 is equal to 0. So from here we can calculate what is RA is equal to WL square by 2, or RA is equal to WL by 2. So RA. So we can calculate RB from this equation, that is RB is equal to WL minus WL by 2, that will also be equal to WL by 2. So if the whole beam is loaded with point load, we can say it is asymmetric loading. So the reaction developed at point A and point B would be equal. So RA is equal to WL by 2, RB also WL by 2. So first we have to calculate these two values, that is what is the RA and RB developed on the supports, that is reaction at support A and support B. Now we will go for drawing the shear force and bending moment diagram. So for drawing the shear force diagram, consider a section XX at a distance x from left support. Okay. Now shear force at XX. So as per definition, what is shear force at XX? Now algebraic sum of all vertical loads acting to one side of the section considered. So at the left side, so for this length, the load is acting vertically downward direction, or RA is acting in upward direction. So shear force at XX is equal to, we can give RA, that is vertically upward direction positive, minus W per unit length, and for X length, that is the total load acting in downward direction in this section. So RA minus W into X, because we have considered this length is X. Okay, what is RA value? So WL by 2, we have got this value minus W into X. Okay, now slide the section to point A. So we will get shear force at point A. So at point A, X value will be 0. So we will get WL by 2. Slide the section to say the center of the beam, shear force at point C. So it will be WL by 2 minus W into X is equal to L by 2. Sorry. At this section, WL by 2 minus WL by 2. Okay, so that will be 0. Now slide the section to point B. So we'll get shear force at point B. So that will be, in this equation we'll put X value is equal to L. So WL by 2 minus W into L is equal to minus WL by 2. Now shear force varies, in this equation shear force varies with X. So that means the variation is a linear variation. Now with this information we will draw the shear force diagram. For drawing, draw these two vertical lines, draw the baseline first. So this is the baseline. Now at point A, what is the shear force? WL by 2 with some suitable scale. Measure WL by 2 length and mark the point, and at point C it will be 0. So that means at point 0, and at point B it will be minus WL by 2. Minus WL by 2, no need to write minus because we are taking in negative direction. Now join these 2 points. So it will give the shear force diagram for the beam. So that is positive and this is negative. Put the hatching lines. So this is the shear force diagram for the beam under UDL for whole span. Now we will go for bending moment diagram. Now bending moment diagram of the beam at section XX. So what is the bending moment diagram? So because load RA, so RA into X, it will give a clockwise moment, and minus this load will cause a moment about section XX, that is load for this section is equal to W into X into the center of gravity to section distance. So this is the center of gravity, from this to this distance is equal to X by 2. Okay. So put the RA value, WL by 2 into X minus WX square by 2. So we have got bending moment at section XX. Now slide the section to point A. Bending moment at point A, where X value will be 0. If we put the X value is equal to 0, so bending moment at point will be 0. Now slide the section to point B. So we will get bending moment at point B, where at point B X value will be L. So we can find from this equation WL into L by 2 minus WL square by 2. So that also becomes 0. So we cannot draw the diagram. So at point C, or center of the beam, if we find bending moment at point C, that will be at point C. So from this equation, WL by 2, X value will be L by 2 minus W into L by 2 whole square, means L square by 4 divided by 2, and it will be WL square by 8. So we have got the bending moment at point A, at point B, and at point C. So with this information we can draw the bending moment diagram. Now one more thing, that is variation. So the curve varies with X square. So that means the variation will be a parabolic variation. A parabolic variation. Now with this information, extend this line, draw the baseline first. All the bending moments are positive in nature. So at the center, so at this point you measure this height with some suitable scale, that is WL square by 8, and draw a approximate parabola. Okay, so this is a parabolic curve, and you have to write here positive because the bending moment is positive, and put the hatching marks. Okay, so this is all about this when the beam is under uniformly distributed load. Now we'll see one more problem under this, that is simply supported beam, that is, so beam is under say UDL plus point load, so it may be the case. So when the beam is under UDL plus point load, let this is the beam, that is a simply supported beam resting over two end supports, and the beam is whole part of the beam is loaded with say UDL and also UDL, that is W per meter length, that is the intensity of load, and say another point load is acting somewhere. Okay, so say at the center it is point load is acting. W is the point load, capital W, and this is the small w. Now for solution of this problem, say let A, B, reaction developed at support A, RA, support B is RB. So from this we can write RA plus RB, and that will be equal to capital W point load plus small w into L, and we have considered this one as a central load. Okay, W plus W into L. Now take moment about point B. If we take moment about point B, so RA into L minus RA into L, and this load will cause a clockwise moment as well as this load will cause a clockwise moment, that is minus capital W into L by 2 minus what is uniformly distributed load acting, the total load small w into L by 2, and that will be equal to 0. So RA into L minus W into L by 2, or minus W into L by 2. So this becomes 0. So RA into L, that will be equal to, this one will be capital W into L by 2 plus WL square by 2. So RA becomes W by 2 capital W by 2 minus plus W into L by 2. So that just you can see this is just the sum. So we have considered two cases separately when W is acting at the center, capital W, and also you have seen the UDL problem. So in this case it is the sum of these two loads. Similarly, we can calculate RB, that will be from this equation, that is equal to capital W plus minus RA value. Minus RA value capital W by 2 minus WL by 2. So it will be also same capital W by 2 plus W into L by 2. So we have got RA and RB. Capital W by 2 plus WL by 2, and here capital W by 2 plus WL by 2. So thereafter we will consider a section here, that is XX section at a distance x from left support, and another section YY section at a distance y from left support. Now the procedure is same. So for solution, first we will form the equation at section XX and section YY for shear force as well as for bending moment, and then slide the section to point A, then to point C, then to point B. Find the shear force at these points, at point A, at point C, at point C, and at point B, and for bending moment at point A, at point C, at point C, as well as at point B. Then whatever the result is coming, accordingly draw the diagram underneath this figure. So that will be your shear force and bending moment diagram for the beam under this condition. Now so from this simply supported beam, so what we have seen, the definition of beam, that is it is a horizontal member which one of the dimension is much larger than other two dimensions, and which takes all the loads vertical to its axial plane. So that is the definition of beam. The definition of shear force, the average sum of all the vertical forces acting to one side of the section considered, whether it is right side or left side of the section. So for cantilever beam we are moving from right to left, and for simply supported beam or overhang beam we are moving from left to right. So that is okay, you can move from left to right or right to left, anyone you can move. Now for solving the problem, any kind of load is acting over the beam. So first we have to calculate the support reaction. So in case of cantilever beam as well as in case of this simply supported beam, but for cantilever beam it is always not necessary because we are moving from right, so from three ends, so no need to calculate the support reactions, that may be support moment or support reactions. But in case of simply supported beam, first we have to calculate RA and RB, and then we have to calculate the shear force and bending moment at the respective sections, that is XX, YY, or it may be more number of sections. Then slide the section to its right point and to its left point where the load variation is taking place. Then that information you have to plot on the paper. So that will be your shear force and bending moment diagram. For this also you require to remember the sign convention. So that is also most important. Okay friends, so this is all about this video, and if this video is helpful to you, please subscribe, like and share the video, and we will meet soon with a new video. Thank you. Meet you again.